So, welcome to the February General Meeting of the Kalamazoo Astronomical Society. It is great to see 80 plus people here on Zoom. A scary thing I think is starting to happen. I think we're actually getting used to and adept at using Zoom, which is kind of scary. Maybe we'll come back to that later. So we have a fantastic guest speaker tonight, and let's just jump right into it. So tonight's guest speaker is an astrophysicist with the NASA Exoplanet Science Institute at Caltech, where she searches for, characterizes, and catalogues planets orbiting other stars. In 2018, she was awarded the NASA Exceptional Engineering Achievement Medal for her role with the successful NASA Kepler mission, which discovered thousands of exoplanets and revealed that rocky planets are common throughout the galaxy. She now works on the NASA Transiting Exoplanet Survey Satellite, or TESS for short, to find and study the nearest planetary systems to Earth, systems that will be perfect for further study with the next generation of ground and space-based telescopes. So without further ado, direct from Cleveland, Ohio, is Dr. Jessie Christiansen. Welcome, Dr. Christensen. You may unmute yourself.
Thank you. Can you hear me okay?
We can.
Okay, great. Thanks, Richard, and thanks everybody for having me. I obviously wish under different circumstances it could be different and I could be there in Kalamazoo giving you this talk, but I'm really excited to see you guys tonight on Zoom and to share this talk with you. And I'm super excited by the list of planets that you guys sent me. There were actually some new ones in there. So I've managed to put some of those in the talk tonight, and I hope you enjoy them. So I'll start sharing my screen. The idea behind the talk tonight is a journey through exoplanets in fiction and in reality. So the prompt that Richard sent out to everybody was, what is your favorite fictional planet? And as I said, you guys sent back a really great list. So I'm excited. So let's get through it. Okay, so does anybody recognize this planet? It might help if I put this in front of it. All right, so this is giving it away a little bit. This is Vulcan. This was nominated for tonight's talk by Kevin. Thank you, Kevin. Vulcan, one of the classic planets in science fiction. It's Star Trek. It's the home of Spock. It's very well known. It has appeared in every season, every incarnation of Star Trek has a version of Vulcan. So it's a well-loved planet. Also goes by a bunch of other names. I'm going to make myself a little bit smaller at the top so I can see my whole slide. There we go. Including Vulcanus A2, Navasa 2, or 40 Eridani A2. You'll find out in this talk that stars go by lots of names. Astronomers are really bad at naming things, but really good at giving things multiple names. Okay, let's move on. So let's talk a little bit about the history of exoplanets in science fiction and in science. So more than 2,000 years ago, 2,500 years ago, the Greek philosophers were already talking about this idea of exoplanets, this idea that the stars that we see in the sky, the thousands of stars that the Greeks saw, and now the millions of stars that we know are in our galaxy, that they might have planets around them too. You know, just as good as our sun, they might have planets around them too. So they were actually really hypothesizing this in a purely abstract way, kind of the way we think about multiverses today. Like, let's talk about this really neat idea that we really don't have a good way of testing, but geez, isn't it fun? So they were talking about this idea, like, is Earth singular or common? Is it rare? Is there only one Earth? Is Earth unique? Or could there be other Earths out there? So you can imagine this, this conversation happening 2,500 years ago amongst these Greek philosophers. And Plato and Aristotle actually argued that Earth was unique, that there wouldn't be anything like Earth. Earth was special and unique. Now, we don't really see planets or exoplanets start to appear in fiction until something like the year 1300 AD. Dante's Paradise actually starts to explore in this fictional world the planetary spheres. Back in 1300, they didn't really know how the solar system was laid out yet. They had their thoughts about how it was laid out. And you start to see the planets, Mercury, Venus, Mars, Jupiter, Saturn, the planets they could see in the sky, that you start to see them appear in fiction. So this is really an exciting moment. Like, we're starting to write narratives about the celestial bodies that we see. And Dante was still just using the ones that we could see. All right, coming back to the science side of things. In the Renaissance was an exciting time to be a scientist. There was a lot of, it was a real revolution in the Western world for art and literature and math and science. And I have included this quote here from an Italian mathematician called Giordano Bruno. And this quote is, "There are countless suns and countless Earths all rotating around their suns in exactly the same way as the 7 planets of our system." So I'll leave it as an exercise for you guys to think of which 7 he would have been talking about in 1592. So he's in the Renaissance and he's like, look, guys, there's stars in the sky. They've got planets around them too. There's no reason why our sun is special. He was actually burned at the stake for saying this, because the Renaissance was a good time for science, but it was a bad time for heresy. So the Roman Acquisition, so he was in Italy, the Catholic Church was not cool with people saying that there were other Earths out there. That was just very antithetical to the Catholic doctrine at the time. He also said a bunch of other silly stuff about the church that it was a bad time to say that. But one of the things that he was executed for was arguing for the plurality of worlds, for arguing that there were multiple solar systems out there, basically. And so he was burned at the stake in 1600 for saying this. So I'm glad in 2021 that it's a slightly better time to be an astronomer than it was in 1592. Okay, so then in the literature side of things, in the science fiction side of things, we go through these real periods where, like, the 1700s was a real time for writing stories about the moon. There's many, many works of literature where the moon appears in these narratives, in these fictional narratives. It was the height of writing about the moon. In the 1800s, interest really switches to Mars. So, people have observed the canals of Mars, these cliffs and rivers and stuff they could see that looked like they could have been man-made or artificially made. So Mars becomes the real, subject of the people's imagination. They write all these amazing stories about Mars. But you can see here, we're still kind of like in the solar system in terms of science fiction. All right, coming back to science. So you can see thousands of years of thinking about it. We still don't have a way of doing it. How do we find these planets? The thing is, stars are really, really big and really, really bright, and planets are really, really small and really, really faint. And you have to look next to the really, really bright things to find the really, really faint things. So there was a discussion as everybody was joining about trying to find Sirius B, which is next to Sirius A, which is really bright. And it's quite difficult. Now imagine if instead of looking for Sirius B, you were looking for Earth. The analogy that people use is it's like looking for a firefly next to a spotlight. Like, there's such a difference in brightness and size. It's almost impossible, and was impossible for thousands of years, until in 1952, an astronomer named Otto Struve has a paper. It's a really seminal paper now. He suggests this technique, and it's basically, if you could measure a star's velocity, if you could measure how fast a star was moving, you might be able to see a planet going around it. And this is based on the idea that the stars are pulling on the planets. That's what keeps them in their gravitational orbits around the star. But the planets are pulling on the stars too. So Jupiter is actually pulling our sun around the middle of our solar system. If you're an alien civilization looking at the sun, it's making a little circle with a period of 12 years, which is the orbit of Jupiter in the middle of our solar system. And so Otto Struve was like, well, if we looked at other stars and we could measure their velocity, so sometimes you'd see the star coming towards you and sometimes it would be going away from you as the planet was tugging around. Imagine someone hula hooping. So the star's in the middle of its solar system hula hooping, and you could see that motion. You could see the star sometimes coming towards you and sometimes going away. So he comes up with this idea. The thing is, it really only works. It's really only best achievable if it's a giant planet like Jupiter. Jupiter's one of the only noticeable ones in our solar system because it has the bulk of the mass of the planets. And if that Jupiter was right next to the star, really close to its star, orbiting with a period of just a few days. Now, in our solar system, the closest planet to the star is Mercury, which has a period of 88 days. So Otto is like, look, let's take a giant planet like Jupiter, put it right next to the star, and then the velocity that gets induced on the star will be big enough for us to see. And everyone's like, Well, that's neat, but that doesn't make any sense. Like, how would you form a giant planet right next to the star? It doesn't make any sense. You have to be far away to have enough gas separate from the star to form a giant planet. And there's no reason that you would have the giant planet come almost all the way into the star, but not all the way in. It has to stop. It has to, break for some reason just outside the star and then orbit around the star right there. So they're basically like, you're crazy. This is a nutty paper. Go away. So between 1952 and 1995, this paper got like 9 citations, got less than 10 citations. Everybody just thought it was a crazy idea. Anyway, so that was the technique though. Okay, so in film and television, after this idea, in the 50s and 60s, we finally see the first fictional exoplanets appear in fictional works. In science fiction really is starting to take off here, and you see the first planet Altair 4 appear in The Forbidden Planet, a movie that came out in 1956. And on television, the first exoplanet appears in one of my favorite TV shows, Doctor Who. And that's the first time you really see exoplanets appear in film and television, which is really exciting. So 40 years after Otto Struve's paper came out, and this is in the 90s now, so we're well after Star Wars, we're well after Star Trek, we're well after many of these like established science fiction space operas that are exploring the galaxy or other galaxies. Finally, we find the first planet around a star like the sun. And it's using the technique that Otto Struve suggested. We find what we call a hot Jupiter, a Jupiter-sized planet, orbiting a star in just a few days. This idea that everybody said was crazy. So since 1995, this paper, which had been cited like 9 times in the previous 40 years, has now been cited over 100 times because it's the paper that predicted that we would be able to do this if we got the technology good enough. So finally, the whole point of this slide is that after thousands of years, our technology finally caught up with our imaginations. But our imaginations had a really good head start. So one of the things I want to do in this talk is go through the types of planets we imagined, like with really nothing to compare to. What did we come up with? And then what did we find? Because nature is actually, as always, stranger than fiction. Okay. So my day job, as Richard mentioned at the start, so I am at the NASA Exoplanet Archive, and this is how NASA keeps track of all of the exoplanets that have been found. Like NASA keeps a database of all of the planets, where they are, what their parameters are. So my job is to maintain this database. I'm one of the scientists that, makes sure that this is up to date. So one day, a couple of years ago now, I was putting in a planet, and this line of names across the top here, these are all of the aliases for this star. So remember how I said astronomers are really bad at naming things, but really good at giving them lots of names. This is a single star, HD 26965, which has like 10 other names, depending on which catalog you're talking about. And I'm sure a lot of you who are going out trying to find stars in the sky have seen that these stars have multiple names. Anyway, so it's a boring day at work. I'm casually putting in this planet. And then I see one of the aliases, and it's 40 Eridani. And I'm a huge science fiction fan, and I just stop and I just look at the screen for a minute, and I'm like, wait, 40 Eridani, where do I know 40 Eridani from? 40 Eridani is a triple star system in the constellation Eridanus. It's got a bright primary A with a nearby binary, C and B. And if you remember from the start of the talk, is also the name of the star that Vulcan, the planet where Spock lives, is orbiting. So we've actually gone and found a real planet around 40 Eridani A. The reason I have a question mark here is because the real planet that we have found is a Neptune-sized planet. It's an ice giant. It's not a rocky planet like Spock's home world. But one of the things we've discovered since we started discovering planets is that planetary systems are often crowded, are often numerous. So our solar system having 8 planets doesn't seem unusual. Most systems that we find seem like they have multiple planets in them. If a star's capable of making planets, it usually just doesn't stop at one. So the fact that we have found one close-in ice giant around 40 Eridani A is really good evidence that there's probably more planets around this star. So maybe there is a rocky planet around 40 Eridani A. Maybe Spock's homeworld is really there. Anyway, that's one of my favorite moments of my career so far, is discovering that there was a real planet around 40 Eridani A. and that Vulcan might one day be real. So we've sort of found Vulcan. We found a planet in the Vulcan system, which is exciting. Okay, so the planet that we found is not like Vulcan. So what I did was go through our database of exoplanets and find the planet that's most like Vulcan if Vulcan was around a different star, if the planet Vulcan was around a different star. This is Kepler 62f. I have to write down the phone numbers of all the planets. And it's a rocky planet around a star like the star that's 40 Eridani A. Discovered by Kepler, which I'll tell you a little bit more about. But this is an artist's impression. So all of these planets are way too far away in general for us to have any kind of picture of. We have some very faint blobs that we can see for some of the brightest, hottest, youngest planets. But typically, especially for rocky planets, all of the graphics I'm going to show you for the rest of the talk are artist animations, are ideas, which genuinely lend themselves, have borrowed a lot from fiction. So Kepler 62f is the closest thing we found to Vulcan so far. Okay, so as an exercise, I went through all of the planets that have ever been named in Star Trek. Now, I did this 2 years ago, so it doesn't include Picard and it doesn't include Lower Decks. For all of the proper Star Trek fans out there who are like, wait, doesn't include Picard or Lower Decks. There are 938 named planets in the Star Trek canon, according to Memory Alpha. So I went through and I tried to identify them. Of the 938, 51 orbit real stars, stars where I could reverse engineer the name of the actual star in the sky. Like maybe sometimes it was Taurus Alpha and I'm like, okay, I'll call that Alpha Taurus. Like I'll give you that one. But there were 51 stars that I could match to a real star in the sky. Of those 51 stars, 7 of them turn out to be real exoplanet host stars. In the real world, those stars in the sky have planets around them. One of which now we know is 40 Eridani A. But another one that I wanted to quickly touch on is Tau Ceti. So Tau Ceti is a naked eye star. You can go out and it's like a 2nd or 3rd magnitude star. You can go find Tau Ceti. It's in the constellation Cetus. I'll show you in a second. And it has 4 planets around it that we know of. So here's the constellation. Here is Tau. Tau Ceti is this one down here at the bottom. It has 4 planets around it. Now, the exciting thing about those 4 planets, the holy grail of searching for exoplanets is finding something that's Earth-like. We want to find a rocky planet that we think is, cold enough for water to not be ice and hot enough for water to not be, other way around, warm enough for water to be liquid, but not so hot that the water is vapor. We need a planet of the right temperature that's rocky around a star like the sun. Now, the reason we got excited by Tau Ceti is it has 2 planets that are basically straddling what we call the habitable zone. So this green region here is what we call the habitable zone. So where it's not too hot, it's not too cold. So it's also known as the Goldilocks zone. And so it's got 4 planets around it, E, F, G, and H. And I'm showing them here basically to scale with our solar system so you can see our habitable zone. And you can kind of see what the drawbacks of the habitable zone are. Like Mars not technically habitable right now, but if Mars was the size of Earth and had an atmosphere as thick as the Earth, it might be habitable. So the habitable zone really only applies to if you put Earth there, would Earth be habitable? You can't put other kinds of planets there and have them be habitable necessarily. But anyway, there's 2 planets in the Tau Ceti system that are straddling the habitable zone. The exciting thing about Tau Ceti, in real life, it has 4 planets. In the Star Trek universe, it has 4 planets. They not only got the star right, they got the number of planets right. Now, these planets are probably too big to be properly Earth-like. They're about twice the size of the Earth, which means that they've probably accreted a whole lot of gas and ice and volatiles. So probably a very thick atmosphere and not very breathable. But they are evidence that there are planets near the habitable zone in this system, which is exciting. So the quote that I would put here is, "It's life, Jim, but not as we know it." So Tau Ceti, they got the number of planets right too. Okay, so I mentioned this planet when I was going through the history. This is Altair 4. Altair 4 was named in the list by Jack, Becky, Rick, France, and David, so I had to include it. The first exoplanet that appears in film is Altair 4, and it also appears in Star Trek in numerous of the Star Trek seasons. So Altair, for the observers among you, is the brightest star in the constellation Aquila, the Eagle. Altair itself does not seem to have any planets around it yet. We've looked, we haven't found any yet. However, there are systems like Altair 4. So Altair, the system in Forbidden Planet and Star Trek, has 6 planets around it. And we have found a 6-planet system. We found a few actually, but the one that I wanted to highlight is one that I thought you guys might actually be able to go and find. So this is HD 219314. I apologize, the names are all garbage. 219314. And you can see, so here's Cassiopeia. So it's about a 5th magnitude star. So it's, if you're at a dark site, you can get naked eye, but it's definitely binoculars. And it has 6 planets around it, including 3 rocky planets, like the Altair 4 system. So for those among you who are excited about Altair 4, the closest analog we found so far, you can go out and find with your eye in a dark site or a pair of binoculars. It's here, HD 219314. So go check that one out. Okay. So we did get, I was pleased to see this because I'm a Doctor Who fan. As I said, we did get someone nominate a Doctor Who planet. So I wanted to spend a minute talking about those. So if you, the audience, had a box that could take you anywhere in space and time, where would you spend most of your time? This is a pie chart of where Doctor Who spends most of his or her time. They spend most of their time at Earth. I mean, this is a budget consideration. And also, the 3rd Doctor gets trapped on Earth for a long period of time. But most of the time, the Doctor is actually just visiting different periods on Earth. Or is visiting now on Earth, to be fair. Sometimes the Doctor is visiting Earth-like planets, which is basically, let's go to a kind of barren part of the LA basin and film there. Sometimes the Doctor is visiting Earth-ish planets, and that's like, let's put a red filter over the lens and make everything look kind of weird, but, we haven't really left the regime of there's rocks on the ground and gas in the air and some kind of biology. Still Earth-ish. Very, very small amount of the time, the Doctor genuinely visits somewhere which is not Earth-like or Earth-ish. It's super uninhabitable, but it's very rare. We'll visit one of those in the next slide. Sometimes the Doctor is just in space, exploring, visiting spaceships. There was the whale in space. That was kind of interesting. And then sometimes the Doctor is just somewhere else, like an asteroid belt or a black hole or something like that. But frankly, most of the time, 80% of the time, the exoplanets that the Doctor visits are Earth-like or Earth. Now, this is actually kind of emblematic of science fiction. We can only go so far when we're trying to reimagine new worlds. And the thing is, if you want to have humans live there, it needs to be Earth-like. Otherwise, you're talking about terraforming or life support systems. So, I'll forgive the show for doing this because it's not unusual in science fiction that the exoplanet is just Earth with a different name, or Earth with a different color filter on top. But they did have some truly interesting and unique places that they visited. I just wanted to thank my colleague, JJ Eldridge, who's also on Twitter, for providing the data that I used to make this pie chart. Okay, so one truly very interesting planet that they visit in Doctor Who is called Midnight. This is an episode where the Doctor and a group of strangers are basically stuck in a shuttle on a diamond planet. There's diamond towers and there's like ionizing X radiation from the star. So no one can live there. They're like, in this very protected shuttle. It's a very good episode. It's a David Tennant episode. So one of the things we found, this is 55 Cancri E. So in the constellation Cancer, this is 55 Cancri E. So it's the 4th planet that was discovered around this star. So the way we name planets is we start with B for the first planet, assuming that the star is A. So B, C, D, E. So E is the 4th planet. And we can see from the rock and the carbon to oxygen ratio in the rock that this planet probably has some kind of diamond interior, like a shell inside, which is like crystallized carbon. And what happens when you crystallize carbon and heat it up and squish it a lot? It turns into diamond. So this made a bunch of headlines a few years ago for being a diamond planet. There were all these like, Tiffany's, eat your heart out. It's a 1 million carat diamond. So this is kind of like Midnight. I mean, we think the surface of this planet is liquid molten lava because it's a rocky planet right next to a star. So that kind of puts a little bit of a damper on the tourism industry there. But we have found planets that seem like they have layers of diamond in them, which is pretty cool. And yes, the name of the episode was Midnight. Okay, the Doctor Who planet that actually got name checked by a member was Gallifrey by Karen. So here's a picture of Gallifrey. So what we know about Gallifrey is that it is a rocky planet. Cool. We found rocky planets. We know those exist. It's a red planet. Yes, we have found planets that are dry and don't seem like they have much water and have red stars in the sky. So very conceivably, you could have something like a red planet. Here's the trick. Gallifrey, if we go back to the picture, it's orbiting a double star. And we have actually found planets orbiting double stars. So this one is Kepler 47. I'm showing this one because it has 3 planets around it, and Gallifrey is in a 3-planet system. But this is actually one of a few dozen, we call them circumbinary planets because they're going around 2 stars, a binary star system. And, you know, you guys, I'm sure on your observing nights have seen stars like Albireo. There's lots of binary stars that we can see. So this is 3 planets orbiting a binary star system. So this is as Gallifrey-ish as I can get, Kepler 47, and it has rocky planets in it. So that's pretty cool. We're getting close. We haven't found evidence of any blue boxes coming out of them yet, but we're still looking. We'll see if we see the Doctor yet. So it's plausible. Gallifrey, but we haven't ruled Gallifrey out yet. Okay, I wanted to take a few minutes to talk about the NASA Kepler mission, which Richard mentioned at the start of the talk. So this is where I have spent the last 10 years of my career, is working on NASA Kepler data. So the NASA Kepler mission was a 1-meter telescope that was launched in 2009. This is just a beauty shot flying around. So this whole thing, so the aperture, the opening is 1 meter. So the whole thing's the size of like a small van. And the goal of the Kepler mission was to work out how common planets like the Earth were. So rocky planets in the habitable zones of stars like the Sun. So now we've touched on all of those topics in this talk now. So now you're all experts. You know what Kepler was looking for, planets like the Earth. In particular, how common were they? Really getting back to this question that Plato and Aristotle were asking thousands of years ago. Are planets like the Earth common or are they rare? The reason that's an exciting question, obviously, is the only place we know where life arose is Earth. And if there are many Earths out there, that might increase our chances of finding life in the universe, which would be, you know, just incredible. So that's why we're convincing NASA to spend hundreds of millions of dollars to let us launch the spacecraft so we can find out how common planets like the Earth are. So how did we go? This is a schematic showing a bunch of interesting planetary systems that we found compared to the Earth and the Sun. So here's the Earth and the Sun up here. So all of the stars in this graphic are to scale with each other. And all of the planets in this graphic are to scale with each other in terms of size. But the stars and the planets aren't to scale. But just to get it all on the same plot, we've made the stars to scale with each other and the planets to scale with each other. So I'm going to walk you through each of these: Kepler 20e, Kepler 22b, Kepler 186f, and Kepler 452b. Okay, so Kepler 10b was the first rocky planet that we found. It is in a very short orbit, less than a day. So what happens when you take a rock and put it right next to the star? It melts. It's a lava world. So 55 Cancri E, which I mentioned before with the diamonds, is another example of a lava world. And the reason this is exciting is because we've got lava worlds in fiction too. This is Mustafar. This is the Anakin, I have the high ground world where Darth Vader is remade. Anakin Skywalker loses. Dun, dun, dun. So Kepler 10 is an example of a lava world as George Lucas envisioned a long time ago now. I just will stop here and say, the reason this was exciting for Kepler is it was the first Earth-sized planet we found. So it was the first proof that the telescope could find Earth-sized planet, but it wasn't Earth-like at all. Okay, this is Kepler 22b. So this planet is more than twice the size of the Earth. So as I was mentioning before, that means it's probably too big to just have like a rocky surface with a thin atmosphere. We think it's so big that the gravitational pull helped to accrete a lot of gas and material when it was forming. So it's got like a very deep, thick atmosphere, very much unlike the Earth. But it is the right temperature. So the reason we were excited about this one was it was the first one that we found in the habitable zone of a star like the Sun. So that was really exciting. So now we had two pieces of the puzzle. We had a rocky planet that was too hot, and we had a big planet that was the right temperature. One thing that was exciting about this planet was that it was the density of water. Basically, the bulk density of the planet was the average density was water. So this could just be something that we don't have in our solar system, which is an ocean world, like probably some kind of rocky core, but maybe a very large amount of a very deep ocean of water. Which we've also seen in fiction. Kevin Costner's Waterworld is a movie where, it's a fully ocean planet. And a little aside, one of the very first planets that we found like this with the density of water is GJ 1214b, which our team promptly nicknamed Kevin after Kevin Costner because it was the first water world that had been found. So when you talk to astronomers, often these planets, they have these terrible telephone number names. Often they have nicknames as well. So GJ 1214b is nicknamed Kevin because it was the first water world. Okay, so this is a planet that's the right temperature, but it's too big. This is Kepler 186f. So this is a planet that's the right size and it's the right temperature, but it's orbiting the wrong kind of star. So this star down here that you can see, the reason it's so dim and red and far away is because it's an M dwarf. So our sun in our sky is just a boring, bright G star, 5,500 degrees, pretty warm, pretty yellow, pretty boring. Most of the stars in the galaxy are actually M dwarfs, so much smaller, much cooler, much fainter. What that means is that the planets can get much closer without getting too hot. So planets can be in the habitable zones of M dwarfs and have periods of 2 weeks or months. Like they go around their stars very quickly, but because the star is so cool, they're not too hot. So Kepler 186f is a rocky planet around an M dwarf. Where have we seen those in science fiction? Krypton, Superman's home world, is a rocky planet orbiting an M star. Because the thing is, when Superman comes here and the light from the yellow G star hits him, he's got superpowers because he's from an M dwarf. And so Krypton was on the list because of Randy. So thank you, Randy. So we're close. This is exciting. We have a rocky planet around an M dwarf. Now, in terms of Kepler and searching for Earth-like planets, we weren't really excited by this because we don't know if planets around M dwarfs are actually habitable. M dwarfs put out a very different radiation profile from G stars, as Superman discovered. And it's unclear whether the sort of chemical processes that created life here with, DNA chains building and protein chains and all that stuff could work on something like a planet around an M dwarf because there's so much X-ray radiation and there's so much UV radiation. And those are really bad for life on Earth, X-rays and UV. That's why we have like the lead aprons and the SPF 50 because we don't like X-rays and UV. So it's a little unclear whether these rocky planets are just fully sterilized by the star, putting out all this UV and X-ray, or whether you can actually have life, some kind of life evolve on them. What's exciting is that it seems like rocky planets in the habitable zones of M dwarfs are super common. M dwarfs, which are 75% of the stars in the galaxy, seem like they're very good at making rocky planets, very good at making multiple rocky planets, and very good at making planets in the habitable zone. So if these kinds of planets turn out to be habitable, that's incredibly promising for the amount of habitable real estate in the galaxy because M dwarfs just seem to make these planets real easy. Okay, so this is Kepler 452b, and this is as close as we got with Kepler to finding an Earth-like planet around a star like the Sun. So it's the right temperature, and it's a star like the Sun. It's a little big. It's about 1.5 times the size of the Earth, which is right where we think that things start to get dicey, whether it's got a rocky surface or whether it's got one of these very thick atmospheres that would mean the pressure at the bottom was just so high that the temperature at the bottom of the atmosphere could be thousands of degrees instead of the balmy, 100 degrees that we need. So this is Kepler 452b. The main problem with Kepler 452b is that it might not be there. We have a lot of noise in the Kepler data that looks a lot like the signal that we see when we look at Kepler 452b. So it's a little bit hard to tell whether or not it's a real planet signal or a false positive, we call it. You know, we thought it was something, but it's really not. So given all of the statistical tests that we can run on the data, we give this about a 50-50 chance of being real. Maybe real, maybe a glitch in the data. And if it's real, maybe rocky, maybe not. But this is as close as we got, Kepler 452b. Now, one of my favorite Earth-like planets in science fiction is Caprica. I love Battlestar Galactica. So have we found a Caprica? Not yet, which is kind of a bummer for a mission whose sole goal was to find Earth-like planets. But we did find hundreds and thousands of planets. So I'm just going to spend the last few minutes talking through some of the things that we did find. So we didn't find Earth-like planets, but that's not the end of the story. We did find Tatooine. So this is, you know, George Lucas in the 70s has this vision. This is Luke Skywalker on Tatooine watching this binary sunset. And as I mentioned before, we've seen planets in binary systems. The very first one we found was Kepler 16. So the first one of these circumbinary planets was found with Kepler, Kepler 16b. And the reason I like this is he even got the colors right. Like, he didn't get the sizes right, but, you know, this was literally before we had found any exoplanets, let alone planets around binary stars. This was before we'd found a single one. And he's like, oh, yeah, yellow star and a red star, that looks good. It's like, dude, spot on. So we found Tatooine. That was very exciting. This is a microlensing planet. So microlensing is a really fun way of finding exoplanets that relies on gravity and general relativity. And that's all I'm going to say, because after that, it just becomes magic, unless you're Einstein. But let me spell it out for you. It's OGLE 2015 BLG 0051b. I'm so sorry. But this is the furthest away planet that we've ever found. So this planet is 26,000 light years away. It's right towards the center of the galaxy. It's pretty close to the center of our galaxy, looking in from where we are out on one of the spiral arms. So in fiction, the closest I found to this was Vormir. So any fans of the Marvel Cinematic Universe out there will remember that Vormir is the planet like at the center of celestial existence, which I'm going to reframe narratively as the center of the Milky Way galaxy. And this is the closest one we found. Also, it's cold and barren. So I was like, that feels pretty Vormir to me. Okay, we did get Mike ask about Arrakis. So Arrakis is a desert planet orbiting a red giant. So red giants is something that happens to stars at the ends of their main... So stars like the sun spend a lot of time burning hydrogen. That's kind of their main job for most of their lives. They're just going to kick around and burn hydrogen. But at some point, they run out of hydrogen and they need to do something else. And a lot of stars will basically become red giants. So you might have heard that the sun in like 5 billion years will evolve to, you know, become this red giant, and it will be as big as the Earth's orbit. Like, it's going to get so big that the surface of the sun will come out to the Earth. That's a red giant. So Arrakis is a planet it's a desert planet orbiting a red giant. In the story, it's orbiting Canopus. We haven't found any planets orbiting Canopus yet, but we have found planets orbiting red giants. So one of the things that, you know, we're very anthropocentric, right? We live here. We want to know what's going to happen here. We live here. What's going to happen to the Earth when the star turns into a red giant, right? Are we going to get swallowed up by the sun? Will our orbit drift out as the sun expands and like the center of gravity in the solar system is changing? What's going to happen to the Earth? So it's kind of reassuring to know that there are planets that survive around red dwarfs. They don't all just get swallowed up. Some of them survive. We don't know what's going to happen to the Earth yet, but we know that some planets survive around red dwarfs. This one, terrible name, HD 212771, is an example of a planet actually just found by TESS, which Richard mentioned and I'll end on in a minute, around a red giant. So we haven't found Arrakis, but we have found planets like Arrakis around red giants. We've also found some things that don't really have very good analogs in fiction. And this is partly where I get to the, you know, space, nature, truth being stranger than fiction. This is an infographic showing TRAPPIST-1. So TRAPPIST-1 is this red star here. TRAPPIST-1 is about as small as a star can be and still really call itself a star. It's about 8% the mass of the sun. So it's right on the hydrogen burning limit. If it was any smaller, it wouldn't have enough gravity to burn hydrogen. So it wouldn't get to do all of the exciting things that stars do. So it's very, very, very small M dwarf. And it has 7 rocky planets around it, 3 of which are in the habitable zone. So that's all really exciting. But the reason I wanted to highlight it is it's an example of one of these new kinds of systems that we're finding that are incredibly compact and packed. So they're very small and they're as stacked with planets as you could be without becoming dynamically unstable. So all 7 of these planets have periods of 40 days or less. So remember, I said Mercury is the closest planet to our sun with a period of 80 days, 88 days. This is 7 planets inside half of that, 40 days. And the only way that works is because the planets are in resonance with each other. So their periods are related to each other. We see that in our solar system too. So the moons of Jupiter, the Galilean moons, 3 of them are in a 4:2:1 resonance. Their periods are related to each other. It's like a clock. And Neptune and Pluto are actually in a 3:2 resonance. So we see these resonances in our solar system. But this is a chain of 7 planets all orbiting their star in this chain of resonances. This is another example that I like to highlight, K2138, not just because I got to discover it and publish it, but because it's a very cool system found by citizen scientists. So one of the ways you guys can get involved is citizen scientists. So all of the data from Kepler and now TESS are online for people to look at and help us find planets in. And so K2138 was an example of a system. So it has 5 planets in a chain of resonances. Now, the resonances here are all 3:2 resonances. So the inner planet goes around 3 times for every 2 times the next one goes around, and it goes around 3 times for every 2 times the next one goes around. And the reason that's interesting is because resonances in music are like intervals, are like notes. So different notes have different frequencies. And the 3:2 resonance is the perfect 5th interval, which anybody who knows music theory, the perfect 5th interval is like the tonic chord, 1 to 5. So this system is making music. And then this group in Canada actually turned this into a song. So what they do is every time the planet transits, every time the planet goes in front of the star as we would see it, it plays a note, which is the frequency of that period. And the thing is, because the frequencies are all related, it sounds beautiful. It's harmonic. It's a song. So let me play it. Let me make sure I'm turned up. This is just your moment of zen at the end of the talk. And the reason it sounds pretty is because of the resonances. They're actually musical intervals. Okay. And I just want to highlight again, I'll stop the music. This is the citizen science website that you can go to, planethunters.org, which we finished with all the Kepler data, but now there's TESS data there, and I'll talk about TESS in just a moment. And this is absolutely something you can just do at home. You can just look at the data and help us find the little blips that are caused by planets. It only takes you like 2 minutes to work out how to do it. And then every single eyeball on the data that we can get is planets. Something like 20% of the candidates that TESS has found were found and contributed by the community. So you guys could help us find planets. So when I published this paper of these 5 planets, I included 5 citizen scientists on the paper, 1 who contributed to each discovery. So I was very privileged to be able to do that and felt so honored to be able to include these people on my paper publishing this system because they'd helped discover it, which was super, super cool. So if you are stuck at home during the pandemic with nothing to do, please feel free to go to planethunters.org and help us find more planets. And maybe you could be on a paper, and maybe next time I give a talk to Kalamazoo, I can show your system. I'm going to end by just mentioning TESS. So Kepler was the mission that I've spent most of my career on so far. It ran out of fuel in 2018. So NASA launched the TESS mission, the Transiting Exoplanet Survey Satellite. So where Kepler was a 1-meter telescope that looked at one part of the sky for a long time. TESS is these are four 10-centimeter telescopes. That's 4 inches. I bet half of you own telescopes bigger than 4 inches. So it's 4 telescopes that are 10 centimeters in diameter. And it's doing a tile of the whole sky. It did the southern sky for a year, and now it's doing the northern sky, and now it's going to do the strip in the middle that it missed. So it's doing a whole sky survey for planets around bright stars. So it has a different science goal than Kepler. Kepler was looking for Earth-like planets. TESS isn't looking for Earth-like planets. TESS is looking for all of the planets that are around the brightest stars that we'll spend the next decades and centuries investigating. These are the stars around our closest neighbors. These are the planets around our closest neighbors, the stars that we can study the best with our telescopes. And this is really where the exciting future is. And I'm so excited to see like what fictional planets we discover next. And to hear from you guys if you have any questions about the talk. Thank you so much.
All right, fabulous. So let me give everyone the opportunity to unmute themselves, and we can do some questions. So you should.
What should I go through the ones in the chat?
I don't. Yeah, you can look through the chat first, and then people can unmute themselves now and ask there.
Okay. How about the planet in the 3-body problem? That's the series by Cixin Liu. But George, you might have to remind me the specifics of the planet, if you can unmute. I'm not sure if George is still on.
It's definitely unchecked, so people are.
Now I am. Okay. Can you hear me now?
Yes.
Yes.
Okay. Well, in that story, particularly the first volume of the trilogy, the mechanics of that tri-star system, triple star system, were so complex and unpredictable that the people on the planet always had a limited amount of time in which to build their civilization before it was destroyed again. Right. And that those intervals, because the dynamics of the 3-body system, it was very difficult to predict how long any civilization would survive. So it's I don't remember if the planet actually even had a name, but there were inhabitants.
Yeah, I remember they were called the Trisolarans, right? Because they were the 3 stars. We have found planets in triple star systems. So for instance, Forty Eridani, the Vulcan system, has 3 stars. So typically, when there's multiple stars, typically you need one of 2 scenarios. Either the planet is so close to one of the stars and the other star is so far away that you can basically ignore it in terms of the 2-body gravity solution that you're looking for, that's okay. Or the 2 stars are so close together and the planet is far enough away that the planet can kind of treat them like one gravitational well that those 2 stars are in. Those are kinds of the 2 situations. So I think the fun part of Cixin Liu's story is, if you had something quite chaotic, if you had 3 stars that were all fully interacting with each other, what would that mean? And one of the things we really do think about is, what is the duration of habitability of a world? So for instance, Mars was probably habitable early in our solar system. Our star was warmer, our star was hotter when it was younger, and then it cooled down and became the star that we know today. And when it was hotter, Mars was hotter and it could have been wetter. So we see water and evidence of water on Mars today. So early in the solar system, Mars might have been habitable, but it might not have been habitable for very long. And that's actually one of the reasons why planets around M dwarfs that I mentioned, the 75% of the stars in the galaxy are M dwarfs, that's why they're kind of exciting, because M dwarfs live for billions and billions and billions of years. Like no M dwarf that was born has ever died, because M dwarfs are just so small and cool. They just, are burning their hydrogen so slowly. They just live for tens of billions of years. So potentially planets around M dwarfs have eons to become habitable and stay habitable and to evolve a civilization that has time. Because, our sun, again, in 5 billion years, we're kind of capped here. Earth has a certain window that it's habitable for, our Earth, which is scary to think about. But if you're a planet around an M dwarf, you might have literally tens or hundreds of billions of years. So the duration of habitability is really really something we're thinking about.
Well, thank you very much.
No worries. Okay, Mike says Avalon in orbit around Tau Seti, Niven and Pornell's legacy of Horo. Did you want to mention that, Mike? Was there a question? Did you just want to bring it up?
I just wanted to mention it because it's an interesting story.
I haven't read it.
Oh, okay. Larry Niven and Jerry Pornell wrote a series of interesting books that were all kind of different, I don't know, universes, if you will. I mean, Larry Niven had his versions, a lot of short stories, but Legacy of Hero is one of 2 or 3 books. And then The Mote in God's Eye and The Gripping Hand is a sequel to Molten God's Eye, where you've got a planet called the Mote, sometimes referred to as Motes, in the Trans-Colsac region. It's actually a planet embedded inside of a dark nebula that has a very small sun. And they're both really interesting stories. And
and that kind of relates to Kevin's comment about Magrathea, planets in dark nebulae. Yeah. So yes, those are hard to find. I'm sure. Most of the ways that we find planets rely on looking at the star and detecting changes in the star. So either the planet blocks some of the light from the star, or it pulls on the star, or the star and the planet go in front of a background star and act as a lens. That's microlensing. So the way you would find, like, for instance, a young hot planet in a dust cloud is if it was emitting heat. And then if you looked with an infrared telescope and you could see that this cloud was hotter than it should have been for being a cloud, maybe you could deduce that there was like a young something or other happening in there.
Yeah, in the Mote in God's Eye, the reason it's so interesting is because they have this Trans-Colsac region near the Colsac, and they see a bright eye suddenly appears in it. It's very bright red. And then as this called the Co-Dominion is kind of a blend between the United States and the Soviet Union. And they send a ship to look at it. And then this thing goes, this bright light turns off. And then they find this ship. And it turns out that this was a big laser and had a light sail shoving this spacecraft out of the moat, out of the Colsac region. And the problem is when they actually explore it, they find out that it's a closed evolutionary system, and they just go through these cycles of destroying and rebuilding their civilization, and they reproduce at a tremendous rate. These creatures reproduce at a huge rate, so it's obviously we can't let them out because they'll just overwhelm the galaxy. It's a really fascinating series of vignettes built into a great story.
Oh, that does sound good. I wrote down the title. Thank you for letting me know. Okay, Jerry says, I'm such a Doctor Who fan. Thank you. You're welcome. I'm also a big Doctor Who fan.
Bye-bye.
All right, Magrathea, we talked about. All right, Mohammed asks, how good are the chances of Gliese 581d harboring life? I would say not good, because it turns out that that Gliese 581d doesn't exist. We actually removed that planet from the archive a few years ago because it turns out that one of the difficulties when you're measuring the velocity of the star to find these planets is the star itself can be doing its own thing, like star spots are coming and going, and they actually introduce noise into your measurements. And as the star's rotating, those star spots come and go. The stars have magnetic cycles like our solar cycle. So there's a whole bunch of interesting stellar activity that can masquerade as a planet signal. So unfortunately, Gliese 581d, which people were excited about for a little while, turned out to just be fake. It turned out to be stellar activity. So that one doesn't have a good chance of harboring life, I would say. Thank you. No worries. All right, what's good software to use for luminosity method to identify exoplanets? Oh, so if the amateur astronomers out there are interested in going and observing exoplanets, AstroImage-J is the software I would recommend. It was written by some astronomers and amateur astronomers who do this, who look for exoplanets. So AstroImage-J, go and look that up. It's, as far as I can tell, the best one out there for people to use in terms of usability and functionality, and being able to upload really astronomy publication worthy results, like in terms of plots and analysis and stuff. Okay, any more questions? What about rogue planets that have been ejected from their host star, like the episode Rogue? Is there any data on these? Mary, yes. I didn't really get to rogue planets. So one of the things we've discovered is that there are planets just floating out there in between solar systems that seem to have either formed in situ, formed, from a little gas cloud that was just too little to make a star and it just made a planet instead, or to have been ejected from a solar system. And there's, we're still working out the history of our solar system. And there's one theory that we had an extra giant planet that we ejected at some point. And in fact, the hot Jupiters that I spoke about right at the start, these planets where it's a Jupiter-sized planet that we find right next to the star, one of the potential explanations to solve this, complaint that everybody had, how would you make a giant planet right next to the star, is that you make the giant planet far away, you make another giant planet like Jupiter and Saturn, and they interact with each other. They like slingshot around each other dynamically early in the solar system. One of the planets gets flung in towards the star and the other planet gets flung out of the system. And that's one reason these rogue planets might exist and explain this population of hot Jupiters that we see. So we see these in two ways, either with microlensing, which is the one where I said that the planet goes in front of a background star and acts like a gravitational lens. And so you see the brightness of the background star suddenly get brighter. It's like holding a magnifying glass over it. And that, like, you just see, oh, it was a little tiny thing out there. Or if they're still releasing some heat, you can see them in the infrared. Infrared surveys will find these very small, cool lumps floating through space that are rogue planets. So yes, we have found them. For a little while, we thought that there were many, many, many rogue planets, possibly as many rogue planets as stars in the galaxy. That might have been an overinterpretation of some early results. The jury's still out. That's an active area of research right now, like how common are they? NASA is going to launch the Roman telescope in a few years. So this is what was called W first and is now called Roman after Nancy Grace Roman, the mother of Hubble, we call her. So she, that telescope will be able to find more of these, and that'll help us put constraints on how common rogue planets are. Okay. Yes, so the orphan gas giants we just talked about. The Pi planet. So there was a planet that we found with a period of 3.14 days that we nicknamed the Pi planet. Again, they get nicknames because the names that they actually have are garbage. What technologies are in development or envisaged that will enhance our ability to find and analyze exoplanets? Okay, so the next big cool thing is being able to directly image these planets. So remember, I said it's very hard. They're very small compared to the star, and they're very faint compared to the star. But a lot of people, a lot of different teams around the world are working on technology now, very advanced technology that would block out the light from the star in very clever ways and be able to image the planet next to it. So NASA has studied over the last 5 years several big flagship mission concepts that would fly in the 2030s or 2040s that would basically be able to image planets like the Earth, like actually be able to resolve a planet and see like, oh, look, that's blue and that's green. And then actually what you would do then is you would put a spectrograph on that. You would take the light from that planet and spread it out and look for wavelengths that were missing because stuff was absorbing. So you would look and see, is water absorbing? Is carbon dioxide absorbing? Is methane absorbing? And then you start looking for biosignatures. Biosignatures are evidence of life. So that's what we're really excited about next, being able to directly image these things. And that's a technology that's still, we're not there yet. We don't have the sensitivity yet to do this, to really directly image Earths, but we believe we see the path there over the next 20 years to get to being able to image Earths, which is really cool. Okay. Is the number of stars in a system a big detriment to finding planets? The planet in the story Nightfall is in a 6-star system. Yes, actually, we just found a 6-star system like a week or two ago, which is really cool. It's like 3 pairs of binaries that all orbit each other. There's like a pair of binaries here that's orbited by a larger binary. It's a 6-star system. It does make it more difficult, and it makes it more difficult to work out the properties of the planet. The thing is, if there's 2 stars, they're introducing a lot of their own personality into the data. So the planet just has to work that much harder for us to be able to see it and understand it and measure its size and measure its mass. So it both makes it harder to find them because there's just so much more going on. And once you found them, it makes it harder to work out exactly what they are. And it's one of the big problems that we're trying to solve today, especially in big surveys like Kepler, where you looked at 200,000 stars. You don't know how many of them were binaries. So you have to kind of marginalize over the statistics and say, okay, we would guess that maybe 50% of them are binaries. What does that mean for our ability to detect Earth-like planets? And it hurts it as you guess. Any news on exomoons? Ooh, what a great question. So, taking what I've said further, we started with thousands of years ago, the Greeks are like, there are stars in the sky, maybe they have planets around them too. In our solar system, almost all the planets have got moons. It's actually rare for a planet not to have moons. And most of the planets have multiple moons. So taking this inference further, if planets are common and planets in our solar system commonly have moons, then moons are common, which is so cool. Now, if you imagine how much harder it is to find a planet than a star, now imagine how hard it is to find a moon as compared to a planet. So it's, at the moment, it's still just beyond our technology. We're not quite there yet in terms of our sensitivity. People tried very hard to do this with Kepler, and there's one candidate from Kepler called Kepler 1625bi, there's the jury's still out on that one. There's good arguments that it's a moon. There's good arguments that it's some kind of artifact in the data. So, yes, we have one candidate, but no true robust, everyone believes it detections of moons yet, unfortunately. But we're on the lookout. And, again, I think everyone would argue that they exist because planets exist and planets in our solar system have moons. So, okay, I think that's all the questions I see in the chat. If anybody else wants to add a question, please go ahead.
Just go ahead and unmute yourself if you have a question and you want to ask it verbally. Okay, it looks like there are none. One thing I wanted to talk about is Kalamazoo.
Yes.
So I guess we should probably bring people up to speed on the little tweet session earlier today as you let's just say you enjoy the name Kalamazoo. And so I mentioned our kind of local slogan, yes, there really is a Kalamazoo. So if anyone knows where, because I've lived here my whole life, and as of right now, I don't know where to go to get a yes, there really is a Kalamazoo t-shirt. So if anyone can mention that in the chat, I'll get in touch with Dr. Christensen here and find out her size preference and mailing address, and I will send you a yes, there really is a Kalamazoo t-shirt. And I don't know if you can see it. I'll give you a
oh, yay,
a KAS lapel pin.
Brilliant. Thank you. Yay. If I was, again, in other times, if I was physically in Kalamazoo, I would be finding a t-shirt because that's brilliant.
I'm pretty sure there's that the t-shirt shop right down the mall has one.
Oh, I have to go on the mall.
Maybe wait. You should wait till you're vaccinated.
Check with the Chamber of Commerce. They used to have them.
Karen says the Spirit of Kalamazoo. I'll have to find out where that is. So I'm sure if I go to the Radisson, there are probably shops that have it, but I'll probably pay through the nose there.
Try the Hallmark stores.
The name actually, I think it's a Potawatomi.
Yeah.
Name means place of the boiling pot. I'm a graduate of Kalamazoo College, and that was the name of our yearbook.
Oh,
the boiling pot. So,
are there hot springs or something? What's the connection with boiling?
There's a low area, Crosstown Parkway and some streets. There are a lot of ponds. There's a low area to Kalamazoo, and they tend to have a lot of mist and fog, you can say.
Oh, I see. That's the steam. I get it. Oh, cool.
That's one theory for the name. I've heard some others too.
Okay.
I found a place.
Okay, well, just leave it in the chat.
Kalamazoo.com.
Okay, so I can order one online, so I don't have to go anywhere and get coronavirus. That's good.
Please don't, to get me a t-shirt.
No, I've been doing good this far. So if there are no more questions, and we'll get you that yes, there really is a Kalamazoo t-shirt, and I will get that off as soon as possible. And we really want to thank you for being here tonight. That was a fabulous presentation, so much so I may actually have to listen to it again. I've never done that, except for writing up the minutes, but that's no fun.
Well, and you guys were the ones that gave me the list of planets, so yeah, you guys helped build it.
Yeah, I'm glad that worked out
because for listing those.
Because at first I thought you wanted real planets that people liked, and I hardly heard from anyone. But as soon as I mentioned fictional planets, I started hearing about lots and lots of them.
Yes. And I'm sorry for the people who I didn't get to your planet. I'm sorry. As I said, there were some new ones. So I'm going to go look more of those up.
Thank you
All right.
very much.
Yeah, thanks for joining us. You're certainly welcome to stay, but we'll go ahead and transition into the sort of open discussion portion of the meeting. So
No
thanks
worries.
again for joining us. I'll be in touch.
Thank you so much, everyone, for having me. Have a good night.
You too.
Yeah. Good night.
All right, let's go ahead and jump right into the President's Report. So finally, I mailed out some observing awards that I've received over the past, boy, it must have been nearly a year. So I now want to officially present as best I can a Solar System Observing Program Award, a Constellation Hunter Program Award, of course, for the northern skies, and a Binocular Messier Program Award to none other than Aaron Roman.
All right, Aaron.
Aaron, do you have those handy? Do you want to share them, show the pens and the certificates?
Yeah, sure. Hang on a second.
Hang on, I'll see if I can highlight you here. Hang on, we'll make it bigger.
There you go.
There we go.
The,
Big dripper.
Yep. Constellation Hunter. Got the let's see, this is solar system, it looks like. It's got Saturn in it.
Cool.
I like how it's oval.
Yeah.
I think all the binoculars look the same. This one says
Yep.
Messier on it.
Yep.
So that's all right. The Messier certificate.
Cool.
Backwards
What-
to you.
What
That's
number? Oh, your number what? 1204? Did that say? I couldn't quite see it.
Yeah, 1204.
Wow.
So there's a couple there. Let's see on the other ones. This is the solar system observing. That one I think is more accessible for everybody, but it takes a long time to do it because you got to kind of wait for things to happen. You can't just show up and be like, oh, it's November, I can get this. But that's everything from transits of moons and Jupiter to solar eclipse. But that one's 154, so that's a little bit maybe a more recent program, a newer program.
Mhm.
And then the Constellation Hunters appropriately bordered by all constellations. So
Yeah, they don't even need the certificate border on that one. They should just get rid of that.
yeah, yep. I might even know some of those constellations.
Well, you would think so.
I think so. That
All
one's
right.
250.
Oh, fabulous.
Sweet.
All right. So great job there, Aaron. Okay, let me move on here, give you a quick remote telescope update. Our new flat field screen is still on order. When I talked to, I think Jim, I think it is, at Optech, he was telling me, oh, it'll be, Jeff Dickerman, it'll be out right after Christmas. So, of course, now it's February 5th, and I emailed him twice in January, and I haven't heard a word.
So, Christmas?
Huh?
You ask him which Christmas?
Yeah, I guess I should have asked him specifically which Christmas. I was assuming it was after this Christmas, but I guess I should have specified that. So we're still waiting for our flat field screen. Hopefully, we'll get it before Patton heads home to Michigan. And I did complete the new remote telescope users guide. If you are a current remote telescope user, you should have received the new users guide around January 17th. It, I think, is the day that I sent it out. That's the day that I finished it and sent it out, I think. So you should have that. If not, contact me. And I was going to work on a training video around full moon in January, but the weather at Arizona Sky Village has been pretty rotten up until lately. Now it's fantastic, and I wasn't able to do that. Plus, I've been very busy working on this class I'm doing and the lecture series, and so I've been keeping busy with all that other stuff, plus all the other stuff that I got to keep busy with to get by. So I still got to work on the training video. Just a few other short things to mention, just some membership stuff. I still haven't got the KS membership cards out. We have been picking up a few new members lately, but I'm still waiting for a handful of people that I think should renew to renew. And then because I really want to get those out at once. I'm going to have my family, my niece, and them help me stuff those, since we can't do it at like a board meeting. So I'm still working on the KS membership card. So if you are a renewing member or a new member, I will get those. And I just wanted to mention that, of course, if you are a member of the Kalamazoo Astronomical Society, to go to the website, go to the membership menu here, select member profiles. Of course, you can read through the member profiles here, but specifically click on the member profile form. And if you are a member, please create a member profile. I don't have it set here. I don't have the technical know-how to figure out how to add an image here. So when you submit your profile here, it'll take you to a new page that says to send me a picture. Some people don't, because I guess they're shy, but trust me, you know me. Once we start meeting again, I'll start taking pictures, and I'll probably have a list of people I need to take a picture of to put in the profile. So it's just nice to create a member profile so people kind of know who the members are that they might not see very often. And, you know, list your equipment. Maybe somebody will want to buy a telescope that you have, and you could chit chat about it. You know, that's what the club is all about, to help and learn from one another. And of course, right now we're doing, we subscribe to the webinar Zoom feature. Of course, what we're doing right now is the Zoom meeting, but there's also the Zoom webinar, which is what we've been using for the lecture series. And I just wanted to open an invitation. So if anybody out there wants to put together their own webinar for the membership, let me know. Maybe you could do something on cleaning eyepieces, cleaning your primary mirror. You could teach us how to use a image acquisition program or do image processing. Maybe you've given a talk in the past that a lot of new people have never seen. You could re-give the talk again on, you know, for a special webinar. Just, you know, all kinds of stuff. Maybe I could get myself and maybe Sinclair and Kurt Carista. Maybe we could do an Ask the Astronomer webinar where people could just randomly ask questions about any topic they want. So, you know, we're paying good money for this webinar. We might as well use it. And if you've been paying attention to the board minutes the past couple of months, we've been slowly looking for a service online to, you know, to sell and print a new line of KS clothing. And I just want to invite everyone to create your own t-shirt. It can be a Kalamazoo astronomically themed t-shirt. In fact, from our discussion earlier, I had an idea today that we should probably do a Yes, There Really Is a Kalamazoo Astronomical Society t-shirt. I thought that might be fun. But it doesn't necessarily have to be KAS centric. You could make one on light pollution or the Messier Marathon or just observing in general or the planets or galaxies, you know, so this would be a great way for us to fundraise. Of course, we will, you know, the board will check out each t-shirt design, because we don't want stuff like, yes, you know, like astronomers do it in the dark. We don't want anything quite that risque, but you know, come up with some t-shirt designs, especially if you have graphic design skills. Draw something up and submit it, and we'll eventually get on the website. And of course, if you know any good website that gives us the highest commission for t-shirt sales, let me know. Of course, we discussed this at a board meeting, you know, that people said, okay, I'll go check this out, Richard. Then usually as soon as the board meeting's over, they go back to doing what else they were doing before. And so we're still working on that. So if anyone has a great idea of where we can actually host our t-shirt sales site and make the most money, let me know. So that is all I have for the President's Report this month. Shall we move on to observing reports? We have had some clear skies. I mean, yeah, it's crazy cold, but clear skies. So anybody want to share any observing or imaging? Cricket? Cricket?
I got in, I don't know, maybe 5 double stars a couple nights ago.
Oh, great.
But sketching them, and I got any. I want to show the page kind of what.
There you go.
There you go. So you do a sketch on it, and then the magnitude, color, separation, and positions everything, because these things move over time. So it's been fun.
I'll give my observing report. I can't remember, gosh, what day was it now? Pete, you can probably remind me. I think it was Tuesday or Wednesday. Mm-hmm. I ran out to the Kalamazoo Nature Center to Owl Observatory. Of course, I had to walk back there. I can mention this now, but I knew I probably shouldn't drive back there, even though I got the 4x4. I probably shouldn't drive back there because of the snow, but guess what? You can't. They don't have it blocked off with, like a chain like they usually do, and you can move pretty easy. They got it blocked off with porta potties. So there is no getting back to the observatory by car right now. So if we do have the February freeze out, we will definitely have to do it in the parking lot. With all the snow we got recently and the freeze out coming up in about a week, we probably wouldn't be able to have people drive back to the observatory anyway. But I did go out there just real quick because I don't know if you guys pay attention to space weather, but there was a really cool video on there recently where someone actually got video of Sirius, the dog star, showing Sirius B, which is the white dwarf, which they call the pup. And it's about as far from the star as it can get right now. So now is a great time to be able to actually spot Sirius B. So I went out there, rolled the roof off. And by the way, the roof worked fine in the cold weather. So no issues there at all. I didn't think we would. And fired up the Leonard James Ashby telescope, pointed at Sirius, and tried and nothing. So of course, Sirius is really bright. The scene was pretty rotten. I think the cold weather may have even knocked the collimation out of the telescope a bit, but I could not see Sirius B. The only thing I didn't try is to get a piece of tape and tape it over the bottom of the barrel to block out Sirius so I can keep it centered in the telescope. And I couldn't see it because I've been trying to see Sirius B for 25 years, and so I'm still trying. I even tried from the Florida Keys, and I figured if I didn't get it there, I'm not going to get it anywhere. But I did look at the Orion Nebula real quick, but it looked really good, but the sky was kind of bright with all the snow on the ground and all the crappy light pollution.
Richard, I think I was inspired by that same video you saw to try Sirius B, and I went until I couldn't find any of my fingers anymore, and it was getting really cold, but I didn't have any luck. The only time I saw that was it must be 25 years ago with the 10-inch Newtonian. What really struck me about it was the Sirius B was between the veins of the spider and the diffraction pattern they made. And I could see that if you got it underneath that diffraction pattern, you wouldn't see it. It was that dim.
Wow.
And that was the one time I was sure I was seeing it, and other tries since then have always failed.
I'm scheduled to use the remote scope tonight, so I might take like a 1/10 of a second exposure to see if I can pick it up with the 20-inch.
Hey, Rich, can I share my screen and I can show what I...
Yeah, it's still set to share screens, so go ahead. Cool.
Yeah, the last few nights, like Richard had said, I been working on some more of my horse head image, doing H alpha. Horses and dogs were chasing in the sky. So, so I did. I got a total of 25 20-minute exposures through an H alpha filter. I don't know if you can see that. Ooh. So, but this is through the clouds, or the breaks in the clouds here the last couple of weeks and the full moon. So H alpha is definitely worthwhile to get if you can get some good details. So with an 8-inch Ritchie scope in my observatory, which is really nice because I can do it all from inside now and don't get cold.
Hey, every telescope I have is a Ritchie scope. Get it? Get it?
You take this with your C5?
No, no, that's not it. Wait, hold on. I got my C5 version. It's right here. Hold on. Wait. Where is it? That's the C5 version. Right there.
Yeah, that looks like it. That looks like a C5 shot. Yeah. Color, beautiful, big, right? You know.
Yeah.
It is so great to have you back on the club, Pete. So we have to hear about the C5 crap again.
Yeah.
That's awesome.
I had a 114 millimeter little bitty telescope in my backyard. The only time I ever saw with my eyes the Horsehead Nebula was with that telescope. And it was about, I don't know, it was real dang cold. And that's the only time I've ever seen with my eyeballs the Horsehead Nebula. And it was with a 114 millimeter little bitty mirror.
Did you use any filters or?
I'm skeptical.
Yeah, nobody believes it, but it's true. No, it was just
straight.
I wasn't even looking for it. I was just kind of scrolling around. And I said, "Ooh, what's that?" And happened to see it. I have no clue why, but the sky just happened to be perfect, and I happened to be looking in the right place at the right time.
I think that's inverted imagination, then.
No, I didn't even before I developed that.
I believe you because I saw it about 30 years ago when I lived in the country with just my 10-inch Coulter, and it was a really cold night, and I swear I even saw a little bit of red and green in the nebula. And then I got my high power eyepiece out. I swear I saw it. It was tiny, but yeah, it was there. Never again.
Yes, sometimes you just get lucky, right place, right time.
I saw it through a 36-inch dot at the Winter Star Party, and it was definitely there. It was quite obvious. It's Crazy Bob's telescope, Crazy Bob Summerfield. If you've ever been to a Winter Star Party or Texas Star Party, you know who Crazy Bob is. Especially back in the early 2000s. He was much more prevalent back then. Anybody else have any observing? Even naked eye stuff counts. Because we have had clear skies. I know it's been cold, but you can get out there and get a peek.
I've seen Vega rising in the morning.
All right. I mean, summer's coming.
Yeah. Yep.
I discovered that it is extremely hard to roll the roof off over chunks of ice in the observatory rail. So I fashioned a scraper so I can, because my track for my roof is a C channel, and that likes to collect all sorts of moisture. So,
oh man, yeah, that's ice chunks, especially when you're going and all of a sudden chunk.
Yeah, I wish that I had seen our observatory has that T, that little peaked track, and that would have been good.
Well, that's a Matt Borton special.
Why don't you get some gutter heat tape and just tape it on the bottom edge of that C?
The problem is that it's totally off the grid, so there's no electricity out there.
All right, moving on. Anybody want to share any astronomical news and events? There is a big event coming up here in just about 13 days, right?
For Mars landing?
Yeah.
Perseverance.
Perseverance is on the way. Hopefully it won't go.
Hey.
It's going to pull a Mars polar lander. Splat.
Musk didn't make it, did he?
Not because we got to get that helicopter going.
Yeah. Ingenuity, right? That's what they call the helicopter.
Yes.
Yeah, that'll be cool.
Isn't there a conjunction of Venus with Jupiter and Saturn or something coming up?
Not that I have this time of year. I pay very little attention to conjunctions and stuff like that, just because we never get to see them. So,
Richard, you might want to mention about the memberships. Got somebody in chat said, "Do we have student memberships?"
Yes, but we can come back to that because right now we are on the astronomical news portion of the agenda.
Okay,
Okay.
So Pete, you mentioned
we have an agenda and we're sticking with it.
You mentioned Elon Musk. I just wanted to plug one of my former students, Eric Berger. He's a senior space editor with Ars Technica. He just published a book called Liftoff about Elon Musk and SpaceX. And I just got it, very first edition in the mail, just received it today, which was pretty awesome. So if you want to know about Elon Musk and just, what this SpaceX was like, that privatization of space, it just came out, Harper's Collin, and just got his first book published. So
what's
just
it called?
Plug for one of my former students.
What's it called?
It's called Liftoff. Yeah, let me share my screen.
I'll see if I can.
Yeah, see if you can. I can't. I'm just going to share background. Share my camera. There we go.
Okay, you're spotlighted. There you go.
It's called Liftoff.
Okay, cool.
By Eric Berger, Berger.
Sweet.
He was nominated for a Pulitzer Prize for his 2008 Hurricane Katrina journalism with Houston Chronicle, and now he's a senior space editor at Ars Technica. So,
oh wow,
just
awesome.
got his first book, which is pretty sweet.
Nice.
Is it signed?
Absolutely.
Oh
wow.
With a nice comment in there to me. So, not gonna let you read it. It's personal.
No, that's private.
That's private. Personal comment to me. So,
any more astronomical news and events? All right. Moving on. Let's talk about the KAS event horizon, what we got coming up. Just a quick note, there is no board meeting this month. We decided to go ahead and start spanning them out a little bit because frankly, not doing any outreach for obvious reasons. And with the schedule this year, at least set for a little while, we didn't see any serious reason to meet. So I thought it'd be good just take a little break. And plus there's a lot going on this month to keep busy with. So no board meeting in February. So
Dawn,
tomorrow,
let me jump in here, Richard. Dawn, there's a letter that was sent to you that you should get in the mail in the next day or two, and there's a reference to one of the a donation that was made, and that needs to be read at the next meeting.
Okay, I'll take a look at it, and
you'll know which one it is as soon as you read it. So.
You're speaking about the next board meeting.
It could be next board meeting. You might even want to read it at the next general meeting.
Okay.
It's a really nice letter. So
okay, very well.
Okay.
Thanks.
So tomorrow, February 6th at 1:00 Eastern, we have part 2 of the Introduction to Amateur Astronomy lecture series. But let me double back a bit and talk about part 1. I mentioned most of this in the newsletter, so you've heard this already, but for the most part, it was highly successful. We did have, of course, the first 10, 15 minutes where nobody could hear me. That was a total Zoom glitch because, as I described, Lloyd decided to kind of help me out, kind of moderate the chat, check the Q&A, stuff like that. And for some reason, when I was speaking, it showed Lloyd as the speaker, even though he was muted and not sharing video. So, finally his wife had to call me and tell me to stop and start over again. So that didn't go too well. But as of the last general meeting, we had, I think, just under 200 people registered. And then a short time after that, I sent out like one last reminder to, nearly 350 clubs across the country and Canada, and registration just exploded. And I was having a really tough time keeping up with it. But long story short, we currently have over like 810 people that have registered for the Introduction to Amateur Astronomy lecture series. So this has become a major event. I don't think any introductory series like this has ever had such a large audience ever. And as I mentioned in the newsletter, I can't remember all the places, so let me hop to the proper spot in the newsletter. But besides, of course, we had people from the US, obviously. We did have people, at least one person from Hawaii, one person from Puerto Rico, and just about almost every state you can imagine. We had several from Canadian provinces, including one from the Yukon Territory. But we had viewers from Belgium, Bolivia, Colombia, Chile, Germany, India, the Netherlands, Norway, Philippines, and the United Kingdom that showed up for the first part on January 23rd. The only really sad part, besides people not being able to hear me for the first 15 minutes, is I never got to see anybody because we did the Zoom webinar thing, because with we probably maxed out around 477 people that actually signed in. I think it dropped off a bit, maybe because of the technical issue, or people thought I was boring or something. But I think it dropped off to like the 440s. But that was the largest audience I ever had for anything. I've done school assemblies, but I'm sure there weren't that many people in there. But if there were, I could still say this is the largest group I ever had that wanted to be there, because it was school assemblies. They don't want to be there. So I have no idea what's in store for tomorrow, because we have, again, over 800 that have registered, and we have enough room for 500 on Zoom. And then they'll have to go to YouTube, where we have basically unlimited room. And so part 2 is entitled Discovering the Night Sky. And we'll basically get a little history of the constellations, learn about the magnitude system, how to find stuff with a star chart, take a tour of the constellations by season, at least the major constellations, and talk about everything else you can see in the sky with just your eyes alone before you even get to a telescope.
Hey,
Question,
Richard?
Jack? Yeah.
I looked at that link you had from, was it Royal Canadian Astronomical people, whatever, and they had a very good complimentary comments. 3 or 4 of them that had tuned in to see that last session, and they were all very positive about it and sound like they were encouraging others to join for the second session. So that was pretty nice.
Yeah.
Yeah, I watched that as well. It was great. They really talked it up.
And the great thing is at the end of the lecture, I gave a little option to provide a donation to the club, and to date I've received $625.61 for the club. Woo-hoo. And even a little bit of money for me, but I won't bother to mention that. But not nearly $625.61. It's a tiny fraction of that, but it was very much appreciated. So again, part 2 is tomorrow at 1 o'clock. And then later that day, because we got like a triple feature this weekend, we have our last online viewing session of the season. And so again, that's tomorrow, February 6th at 9 o'clock. It's a pretty high percentage it's going to happen. The weather looks good now. The bad weather out there is finally passed. And tomorrow looks to be a good night with clear skies and low wind. And many people have registered, well over 100. So again, people may have to go to YouTube, because we're not doing the Zoom webinar. We're doing the meeting thing like we're doing now. So if we do actually hit 100, which we haven't done yet, people will go off. People will have to watch on YouTube, but it's not too bad. And I just wanted to open it up for those of you that have attended an online viewing session. If anyone wanted to have any comments or critiques or criticisms about ways we can make the sessions better. Did anyone want to have any comments about maybe things you didn't quite like or thought we could change and try different things?
I thought it went.
I already commented to you before, so.
Yeah, Kevin was very harsh. I cried.
No, come on.
I think
it was constructive criticism.
Yes, it was.
Is there somebody else handling the weight room and chat and all of that?
Kevin's done a little bit of that for me, but at least for the past one, he kind of dropped me like a bad habit. So maybe he'll help. Maybe
I was busy that day. I'm actually free tomorrow, so I could probably do the class and the remote observing. I'm free tomorrow, so.
Okay.
Yeah, that would be my only comment. I think it works better that way.
Okay. Well, if anyone doesn't want to share anything, you can always email me for things I could change. Sometimes I wonder if I should show, like, because I try to show some slides as I talk up the deep sky object while we're taking the image, and I show like an info slide with, where it is in the sky, and or its right ascension declination, which I never mentioned, but I show it. But the magnitude, the distance, and a sketch of what it would look like through a telescope. And then I show like a starry night picture to give a general view of where it is, and then like a sky atlas view. I don't know if I need both of those, but
Well, you need to use up to 5 minutes or so.
Yeah, they go by pretty quick. Can I try to throw in a little history while we're taking the image? And when the image is actually on screen, I try to talk about the science of the subject that we're looking at. So I try to keep it moving and make sure there's not too much dead time. And we usually have time to take questions from people and just do general chit chat.
Richard, I enjoy them. I'm fairly new and I really enjoy them very much. Even your warped sense of humor, which is like mine.
Uh-oh.
Uh-oh.
That's troublesome.
By the way, Richard, I don't know if the person who asked about the student membership is still on, but yes, we do have student memberships. And you can look at that online, KS Online memberships, all spelled out there.
It's a pretty easy website to navigate.
Right.
One thing I'm going to push next season when we start up again in November is I'm really going to try to be a little more active to look for other hosts. I know Sinclair hosted one in December 2019. I think, yeah, that's when it was. And Kirk was supposed to do one earlier this time last year, but he had a change in plan. But I think it'd be a lot more interesting if it's just not me all the time hosting and talking about these objects that we're looking at. So, of course, the people I usually have in mind is, Sinclair or Kirk with a good science background, but it can be anybody. Anybody can host. I bet Aaron could do one. Roger could even do one. Pete could probably do one. And, they're all going to be online. We're not going to go back to the sessions at Western. Those were never the way I wanted to do it. I don't think it really was very successful. Maybe we could have tried it longer to build up a following, but it was mostly members with a handful of public. But for the online sessions, we've had, people from all over the country. And I think we usually maxed out around 70, 80 people, which is way more than we even had for the premiere session last year. So I think online's the way to go.
Oh yeah, it just makes sense because, it's a remote telescope, remotely operated. We're operating it online. I mean, the venue should be online, right?
Yep. Okay, moving on. I mentioned we have the February freeze out on February 12th. We did have a freeze out last year. It was clear last year, so that means it's probably going to be rotten this year. And I did kind of check the long range forecast, which of course Canon will change, but it did not look promising. But again, if we do have clear skies for the freeze out, we probably will not be able to drive back to the observatory if the snow does melt because they got it blocked off with porta potties. Of course, we can always.
Should we go to the Richland Township Park? Maybe.
Well, from my experience, if we are going to have snow on the ground, Richland turns very icy. Mike Cook and I went out to Richland one time to spot a comet, and the parking lot was pure ice. So I would not recommend going there. The Nature Center parking lot's a lot safer, and it's still pretty open. They're not bogged down by trees or anything. So yeah,
it does look to be pretty cold next weekend.
Well, it's not called the freeze out for nothing.
Well, from a meteorologist point of view here, we are going to have this basic weather for the next week, and next Friday will be even, and next weekend will be colder. We shouldn't even have temperatures hitting 10 degrees.
Whoa.
But there's going to be snow every day, either system snow or lake effect.
Yay. Thanks for the enlightening news. And I did want to mention, if we do have clear skies,
I'd want it to be 80 degrees and clear. So
if we do have clear skies, the creator of the February freeze out, I don't think he's been to one since the first one. So Sinclair, if it's clear, you need to show up.
If it's clear, I'll be there.
Frozen Coke and all, right, Mike?
Hey, that's a tradition, and I still do. I still go outside, in the spring and the fall, and it freezes the Diet Coke at the bottom, so I'm good to go.
I've seen that twice happen over the years.
Zoom this year, Mike.
I've never seen this. I must
bring your C5 along with you.
Hey.
Ooh, yeah. Then I'll compete with you.
I'm just really sorry I missed the first freeze out because apparently there were crop circles in Pete's front yard.
That was awesome.
I think Henry's still in the front yard. Frozen to his coulter.
Yep. Just like Terrence Dickinson is still in the closet at Camsey, finishing up his talk.
That's right.
Okay, moving on. We have the third installment of the lecture series on February 20th. That one is on binoculars. So if you've already know this constellation mumbo jumbo and are ready to step up to binoculars, you can join us then. Prime focus. The usual deadline for articles is February 15th. I do want to mention the upcoming March issue is number 260. If you've been keeping track, I'm not going to ask for any special articles or anything, but I did want to give thanks to Aaron. I don't know if anyone noticed, for the first time, Aaron wrote both the general meeting minutes and the board minutes, and with all I've been doing with the lecture series, that really did save me precious time from having to write the general minutes, because Roger wrote the board minutes for nearly 20 years, but I've always done the general minutes, and so that really helped, and so I hope Aaron keeps up, but it kind of wears on you after a few years, so we'll see how it goes.
Richard,
really nice article on Roger's observatory. I'm enjoying your series on that, Richard.
Yep.
Richard?
Yes.
As a new member, I really appreciated the article that was in Prime Focus either last month or this month about the history of the club. It was wonderful. I don't know if you wrote it or who wrote it, but it was just really well done and very helpful to somebody new to the club.
The original article was written by Eric Schruer, who has been a member since the late 60s, but it's been heavily modified over the years by me. The full version is on the website, but the version in the newsletter is almost exactly the same. I just had to cut out like a paragraph in the newsletter version just to have room for like another picture and something like that. But I figured since it's our 85th year, it would be good to publish the history article again, especially since we actually know who the actual founder is now, because we did not know that when we had the last article published for our 75th anniversary. So now we know it wasn't just Kalamazoo College students. It was actually a gentleman named Leonard James Ashby that founded the club. And if you go on the website and look at the May issue from last year, I wrote a article on him specifically and was able, thanks to his granddaughter, find a great deal of information about him.
Great, thank you.
Yeah.
Thank you again.
And speaking of the member observatory series, I have one left in the archive. That's Dave Wolf. Dave, are you still here? Or did you bail?
No, he's here.
Okay, so Dave, oh, there you are. You still have not gotten me those new observatory pictures. I don't know how easy it's going to be to get those now. I should have had you, I should have like emailed you before this past Tuesday when it was nice and sunny, to run out there and get me more of a profile pic, because right now you just kind of have a face-on picture that you just see this building and doesn't look like anything. So it would be great to get a better picture if you got one. And after I publish Dave's article, I'm hoping Pete will be next, because he just got his observatory. And if there's anybody else that has an observatory that I haven't gotten to yet, let me know. There is one member that I know that has one, and I've emailed them 3 times already and never heard a word. So I'm guessing he's not going to write one for me, but I'm pretty sure there are other members that have an observatory. So the series, I think, is almost over if I don't start getting some new material.
I got pictures. I'm ready.
Okay.
Got it right.
Sweet. So Pete, you will be in April.
April.
So first do your taxes and then write your article.
Whatever.
Okay. Okay. Other. So I was going to come back to this. So let me go back to the website here. So if you have not done so, you can go to, if this person is still here, again, you can go to the membership menu, go to the online forum. And if you scroll down here, you can see there it is right there. We got a student membership for $16 for 1 year, or $27 for 2 years. And of course, if you live in the area, you can pay the extra fee and use the remote telescope. So there you go. Of course, you have to take proper training. You got to watch the training video when there is one and read the brand new user manual. So, of course, you can send them the form the old-fashioned way. And if you don't want to use the online form, because some people poo-poo on PayPal. So that's my other thing. Anybody else have any other items you wanted to mention or just discuss real quick?
Actually, I do.
Okay.
Since Pete's here and a couple others. Some of you that don't know that the KAS actually does have an Instagram feed. And I'm helping Richard curate it, moderate it, run it, whatever. And we're always needing pictures for the to put up there to showcase the members. So if anybody wants to put their have their pictures up on our Instagram, just send me a picture, what you want, and the info about it. And I will put it up there. And if you've got your own Instagram, I can link it. I can put a link in it to you so people can go to your Instagram and take a look.
And look at this. My picture with my award only has 8 likes. That's a crime.
So that was my pitch.
All right. Thanks, Kevin. Anybody else? Have anything to share? All right, moving on. March meeting preview. We got another great speaker. He is from Seti, but he's also from one of these. I can't remember the exact name of the organization, but a lot of his focus is on Mars. But I saw this talk a while back on Twitter and thought this would be a neat follow-up to the talk we had last March, which was our last in-person meeting. Where I can't remember his name, but the gentleman from MSU came to talk about the Fermi Paradox, and everyone just raved about that talk. So I figured it might be cool to have actually someone from Seti give a similar or a bit different perspective, because the title is N is approximately equal to 1 alone in the Milky Way. So the gist of the talk is he's basically going to make an argument that we're it. There is no other life in the Milky Way. It is just us. And that's extremely depressing and sad from a certain point of view. So that should be another fantastic presentation, and I hope you can join us on the first Friday in March, which I did not write down. Oh, of course, it's the 5th because it's always the same. So yeah, March 5th, again at 7 o'clock, and you can register now, but I know a lot of you don't register till the last second. Well, I did want to mention that at the absolute peak